Hello students, today we are going to study class 10 science chapter 3, that is metals and non-metals. In this chapter we are going to study about physical and chemical properties of metals and non-metals. What is ionic compounds, formation of ionic compounds, properties of ionic compounds and extraction of metals, etc. So let's start with classification of elements. So elements can be classified as metals, non-metals and metalloids on the basis of their properties. So what are metalloids? So elements which show properties of both metals and non-metals are called metalloids. Examples are silicon, arsenic, germanium, etc. Physical properties of metal. What are the physical properties of metals? So physical properties of metals are solid except mercury. Metals are generally hard except sodium, lithium and potassium, which are soft and can be cut with knife. Metals have metallic luster, that means they have shining surface. Metals are malleable, that is metals can be beaten into thin sheets. Gold and silver are the most malleable metals. Metals are ductile, that is metals can be drawn into wires. Metals have high melting points. Gallium and cesium have low melting points. They melt in the palm of the hand. Metals have high boiling points. Metals are good conductor of heat. Best conductors are silver and copper. Poor conductors are lead and mercury. Metals are good conductors of electricity. Best conductors are silver and copper. And metals are sonorous. That means they produce a ringing sound when they are beaten. The above activity shows that metals are good conductor of heat and they have high melting point. The best conductor of heat are silver and copper. Lead and mercury are comparatively poor conductors of heat. So what are the physical properties of non-metals? So non-metals may be solid, liquid or gas. Non-metals are soft except diamond, which is the hardest natural substance. Non-metals do not have luster except iodine crystals. Non-metals are non-malleable. Non-metals are non-ductile. Non-metals which are solids and liquids have low melting points. Non-metals which are solids and liquids have low boiling points. Non-metals are bad conductors of heat. Non-metals are bad conductors of electricity except graphite. And non-metals are non-sonorous. So let's start with the chemical properties of metal. That means how they react with different things. So first of all, we are going to discuss how metals react with oxygen. So metal react with oxygen to form metallic oxide. So how it is formed? When copper is heated, it combines with oxygen to form copper oxide. See the reaction? And when aluminum is heated, it combines with oxygen to form aluminum oxides. So the reactivity of different metal with oxygen is different. Metals like potassium and sodium react vigorously with oxygen and catch fire if kept in open. Hence they are stored in kerosene to prevent burning. If magnesium is heated, it burns with a bright flame. If iron is heated, it glows brightly. If copper is heated, it does not burn but forms a black coating of copper oxide. Silver and gold does not react with oxygen even at high temperature. Some metals like magnesium, aluminum, lead, zinc, etc. forms an oxide layer over it which prevents further oxidation, and they are known as self-protecting metals. So what is the nature of metallic oxide? So oxides of metals like sodium, potassium, magnesium dissolve in water to form soluble hydroxide called alkalis. These react with acid to form salts and water. Oxides of aluminum and zinc, they show both acidic as well as basic behavior, and they are known as amphoteric oxides. So when they show both acidic and basic behavior, and they are the oxides of aluminum and zinc, and they are known as amphoteric oxides. These react with acids and they form salts and water. So how metals react with water? Metals react with water to form metal oxide or metal hydroxide, that hydrogen gas is released. Metal react with water and produce a metal oxide and hydrogen gas. Metal oxide that are soluble in water dissolve in it to further form metal hydroxide. but all metals do not react with water. So metal plus water, it will give metal oxide plus hydrogen gas is released, and metal oxide when dissolved in water, it will form metal hydroxide. Metals like potassium and sodium react violently with cold water. In case of sodium and potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. See the reaction, sodium and water, it produces sodium hydroxide, hydrogen gas is released and lot of heat is produced. Potassium and water, it will produce potassium hydroxide, hydrogen gas, and lots of heat is released. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Calcium plus water, it will form calcium hydroxide and hydrogen gas is released. Calcium start floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Magnesium does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to the surface. Metals like aluminum, iron and zinc do not react either with cold or hot water, but they react with steam to form the metal oxides and hydrogen gases released. See the activity, metals of lower reactivity, they react with water only when it is present in the steam form and when steam is passed over the heated metal. Now how metals react with acid? Metals react with dilute acid to form salt and hydrogen gases released. Magnesium plus hydrochloric acid, it forms magnesium chloride and hydrogen gas is released. Aluminium react with hydrochloric acid, aluminum chloride and hydrogen gas is released. So metal plus dilute acid, it forms salt and hydrogen gas. But hydrogen gas is not evolved when a metal reacts with nitric acid. It is because nitric acid is a strong oxidizing agent. It oxidizes the hydrogen produced to water and itself gets reduced to any of the nitrogen oxide. But magnesium and manganese react with very dilute nitric acid to evolve hydrogen gas. So only magnesium and manganese, they will react with dilute nitric acid and they will evolve hydrogen gas. So how metal react with other metallic salt solution? So metals placed higher in the reactivity series can displace the metal which occupies a lower position from its aqueous solution of its salt. So that means when metal react with others metal salt solution, so it gives first metal salt solution plus metal from the salt solution that we have already discussed in the previous classes, that is displacement reaction. So a more reactive metal displaces a less reactive metals from its salt solution, which is also known as displacement reaction. See the activities. When magnesium displaces copper from copper sulfate solution, Mg plus USO4, it will give MgSO4 plus copper is displaced. Zinc displaces copper from copper sulfate solution. Zn plus USO4, it becomes ZnSO4 plus copper is displaced, and iron plus USO4, it becomes FeSO4 plus copper is displaced. Already we have done the activity of iron and copper sulfate. The blue color of copper sulfate changes to green color. So what is reactivity series of metal? So it is the arrangement of metals in the decreasing order of their reactivity. It is known as reactivity series of metal. The most reactive metals are placed at the top and the least reactive metal at the bottom. So now how do metals and non-metals react with each other? So first of all, reactivity of elements is the tendency to attain a completely filled valence electrons. So metals lose electrons and they become positive ions. So they are known as electropositive elements. That means metals lose electrons and they become positive ions. See the example. The atomic number of sodium is 11 and its electronic configuration is 281. So it has 1 valence electrons. So it will lose 1 electron and forms a sodium ion. Now what are non-metals? They gain electrons and they become negative ions, so they are known as electronegative elements. The atomic number of chlorine is 17. Its electronic configuration is 287. That means it has 7 valence electrons. It gains 1 electron and forms a chlorine. See how there is a formation of sodium chloride. So sodium is 281 and chlorine is 287. So sodium loses 1 electrons and chlorine gains 1 electrons. So sodium and chloride ions, being opposite charge, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride. It should be noted that sodium chloride does not exist as molecules but aggregates of opposite charged ions. Let's see another example of magnesium chloride. So magnesium is 212, that is 282. So it loses 2 electrons, and chlorine is 287, that means it will get 1 electrons. So MgCl2. So magnesium will lose 2 electrons, 1 to each chlorine. So the compounds formed in this manner by the transfer of electrons from a metals to a non-metals are known as ionic compounds, or which is also known as electrovalent compounds. That means when the compounds are formed by the transfer of electrons, it is known as ionic compounds or electrovalent compounds. So what are the properties of ionic compounds? So what are the nature? The physical nature, ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and negative ions. The compounds are generally brittle and break into pieces when pressure is applied. Melting and boiling points. Ionic compounds have high melting and boiling points. This is because a considerable amount of energy is required to break the strong interionic attraction. What is solubility? Electrovalent compounds or ionic compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Conductors of electricity. The conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions which move to the opposite electrodes. So when electricity is passed through the solution, ionic compounds in the solid state do not conduct electricity, but the movement of ions in the solid is not possible due to their rigid structure. But ionic compounds conduct electricity in the molten state. This is possible in the molten state since the electrostatic forces of attraction between the opposite charge ions overcome due to the heat. Thus the ions move freely and conduct electricity. So let's start with the extraction of metals. Metals occur in earth crust and in seawater in the form of ores. Earth crust is the major source of metals. Seawater contains many salts such as sodium chloride, magnesium chloride, etc. So let's discuss some important terms. So rocks, minerals and ores. So rocks. Mixtures of minerals having no fixed chemical composition. Minerals. Any solid compound found naturally in the earth crust. And ores are mineral which contains high percentage of metal for economic extraction. So what is extraction of metal and what is it is known as metallurgy. The process of obtaining metal from ore is called extraction of metals. The various process involved in the extraction of metal is called metallurgy. And the three major steps involved in the purification of metals are concentration of ore, conversion of concentrated ore into metal, refining of impure metals. So all the metals can be categorized into three parts on the basis of their reactivity: most reactive, middle reactive and least reactive. So this is the flow chart to explain the extraction of metals of high reactivity, middle reactivity and low reactivity, how they are extracted. So let's start with the concentration of ore. Removal of impurities such as soil, sand, stone, silicate, etc. from mined ore is known as concentration of ores. Ores which are mined often contains many impurities. These impurities are called ganj. First of all, concentration is done to remove impurities from ores. The concentration of ore is also known as enrichment of ores. Process of concentration depends upon physical and chemical properties of ores. So gravity separation, electromagnetic separation, etc. are examples of processes which are applied for the concentration of ore. So conversion of concentrated ore into crude metals. So ores are converted into oxides and then oxides are reduced to metal. So conversion of metal ore into oxide, it is easy to obtain metals from their oxides. So ores found in the form of sulfides and carbonates are first converted to their oxides by the process of roasting and calcination. So oxides of metals so obtained are converted into metals by the process of reduction. So what is roasting and calcination? Heating of sulfide ore in the presence of excess air to convert them into oxides is known as roasting. See the example, zinc sulfide when reacts in the presence of excess of air, when heated it forms zinc oxide and sulfur dioxide gas is released. What is calcination? Heating of carbonate ores in the limited supply of air to convert them into oxides is known as calcination. Zinc carbonate, when heated, it forms zinc oxide and carbon dioxide gas is released. So what is the difference between roasting and calcination? Very, very important. So roasting, the concentrated ore is heated in the presence of air, and the calcination, the concentrated ore is heated in the absence of air. In roasting, sulfides ore are converted into oxides. In calcination, carbonates ore are converted into oxides. Sulfur dioxide is evolved in roasting and carbon dioxide is evolved in calcination. Not used for dehydrating an ore. Roasting is not used for dehydrating an ore, and calcination can be used for dehydrating an ore. Already examples we have discussed. So what is reduction? Heating of oxides of metal to turn them into metal is known as reduction. So let's start with the extraction of metals of least reactive metal. Mercury and copper, which belong to the least reactivity series, are often found in the form of their sulfide ores. Cinnabar is the ore of mercury and copper glens is the ore of copper. So extraction of mercury metal. Let's discuss the extraction of mercury. Cinnabar is first heated in air. This turns mercury sulfide or cinnabar into mercury oxide by liberation of sulfur dioxide gas. Mercury oxide so obtained is again heated strongly. This reduces mercury oxide to mercury metal. See the reaction. Cinnabar, when heated in the presence of oxygen, it will form mercury oxide and sulfur dioxide gas is released. And when mercury oxide is heated, it forms mercury and oxygen gas is released. Now let's discuss another example of copper. Extraction of copper metal. Copper glens is roasted in the presence of air. Roasting turns copper glens, this is the ore of copper, into copper oxide. Copper oxide is then heated in the absence of air. This reduces copper oxide into copper metal. See the reaction. Copper glens plus oxygen, it will form copper oxide and sulfur dioxide gas is released. And when copper oxide and copper sulfides reacts, they form copper, and copper metal is released and sulfur dioxide is released. So how the extraction of metals in the middle of the reactivity series is done? Iron, zinc, lead, etc. are found in the form of carbonate or sulfide ores. Carbonate or sulfide ores of metals are first converted into their respective oxides, and then oxides are reduced to respective metals. So let's start with the extraction of zinc. Zinc blende or zinc spar or calamine are some ores of the zinc. Zinc blende is roasted to be converted into zinc oxide. Zinc spar is put under calcination to be converted into zinc oxide. See the reaction. Zinc blende, in the presence of oxygen, it will form zinc oxide and sulfur dioxide gas is released. And zinc carbonates, when heated, it form zinc oxide and carbon dioxide gas released. The zinc oxide so obtained is reduced to metal zinc by heating with carbon. Carbon is a reducing agent. So zinc oxide plus carbon, it will form zinc and carbon. So what is thermite reaction? How? So ferric oxide, when heated with aluminium, is reduced to iron metal. In this reaction, a lot of heat is produced. The thermite reaction is used in the welding of electric conductors, iron joints, etc., such as joints in railway tracks. This is also known as thermite welding. See the reaction. When iron oxide reacts with aluminium, it forms iron aluminium oxides and heat is released. One more reaction is there. When metal oxides are heated with aluminium, manganese manganese dioxide, when manganese dioxide reacts with aluminum, manganese and aluminum oxide, and lots of heat is released. So now how the metals of the high reactivity are extracted. Metals of high reactivity such as sodium, calcium, magnesium, aluminum, etc. are extracted from their ores by electrolytic reduction. These metals cannot be reduced using carbon because carbon is less reactive than them. So what is electrolytic reduction? Electric current is passed through the molten state of metal ores. Metal being positively charged is deposited over the cathode. For example, see the diagram. When an electric current is passed through molten state of solution of sodium chloride, sodium metal gets deposited over the cathode. Metal obtained from the process of electrolytic reductions are pure in form. So this is the summary how the different metals can be obtained. Unreactive metal by physical method, less reactive method by heating metal oxide with carbon, heating the metal oxide, and more reactive metal by electrolysis. So next is the refining of metal. Metal extracted from various methods contain some impurities, thus they are required to be refined. Most of the metals are refined using electrolytic refining. So what is electrolytic refining? In the process of electrolytic refining, a lump of impure metal, a thin strip of pure metal are dipped in the salt solution of metal to be refined. When an electric current is passed through the solution, pure metal is deposited over a thin strip of pure metal from a lump of impure metal. In this, impure metal is used as anode and pure metal is used as cathode. That means impure metal is made anode and pure metal is used as cathode. See the reaction. See the diagram. A lump of impure copper metal and a thin strip of pure copper are dipped in the solution of copper sulfate. Impure lump of metal is connected with the positive pole and thin strip of pure metal is connected with negative pole. When electric current is passed through the solution, pure metal from anode moves toward the cathode and is deposited over there. Impurities present in the metals are settled near the bottom of the anode in the solution. Settled impurities in the solution are known as anode mud. So what is corrosion? So most of the metals keep on reacting with the atmospheric air. This leads to the formation of a layer over the metal. In the long run, the underlying layer of the metal keeps on getting lost due to conversion into oxides or sulfides of carbonates, etc. As a result, metal gets eaten up, and this process is known as corrosion. We have seen the example in a daily life, rusting of iron. So what is rusting of iron? How it can be? What are the examples of corrosion? So formation of brown coating of rust over iron, formation of green coating of basic copper carbonate over copper, and formation of black coating of silver sulfide over silver. So how metals can be prevented? How rusting can be prevented? For rusting, iron must come in contact with oxygen and water. Rusting is prevented by preventing the reaction between atmospheric moisture and iron article. This can be done by painting, greasing, galvanization, electroplating, and alloying. So now what is alloys? The homogeneous mixture of two or more metals or a metal and a non-metal is called alloy. So what are the different types of alloys? Ferrous alloys, non-ferrous, amalgams. So what are the properties of alloy? Alloys are the stronger than the metal from which they are obtained. It is harder than the constituent metal, more resistance to corrosion. The melting point of alloy is lower than the constituent metal. Examples of alloys are brass, here 80% copper and 20% zinc. The most common is stainless steel. Another is magnesium, German silver, bronze, etc.